All right, let's talk about hyperbolas. So we define a hyperbola as a set of all points in a plane where the difference of the distances from two distinct fixed point, the foci, is a positive constant. So kind of a weird definition. So let's just kind of think visually to start. So we have a few different options in terms of types of hyperbolas. So we have a horizontal hyperbola, where they're opening up to the right and to the left. And then we have a vertical hyperbola. And you'll see they're a lot like parabolas in that you have a vertex with a focus. And you kind of have that on both ends here, a vertex and a focus, a vertex and a focus. In addition, we have these asymptotes. They're called slant asymptotes because they're not horizontal and they're not vertical. They have some sort of a slope to them. We also have a couple of different axes. So we have what's called the transverse axis here, which is the point from one vertice to the other. We also have co-vertices, which are these points here, which technically are not part of the parabola, but they become very valuable when it comes to graphing. So let's look at the equations as well. So with our equations, you'll notice these are our standard forms for horizontal and vertical. And the only difference is that in horizontal, the x portion comes first. In vertical, the y portion comes first. You'll notice these equations look a lot like the formula for an ellipse, except we're always subtracting in between. With ellipses, it's always addition, but with hyperbolas, it's always subtraction. And in addition, with ellipses, we have a squared minus b squared is c squared for an ellipse. For a hyperbola, it's a squared plus b squared equals c squared. So a little confusing there, but as with practice will come, we'll start to do a little bit better for that. So visually, this a value here represents the distance from the center, which is hk, the center, to the vertices. So if our center is here, this distance here would be a. Same with here. The b value represents the distance from your center to your co-vertices. So from here to here, so that would be our b value. And c represents the distance from your center to a focus, or your foci as plural. The way we write our asymptotes is by using these points here, kind of the intersection of this box that's created by your a and b values. We have a formula that we can use for that. It's using like the center and such, but there may be some ways we can figure it out more visually. So let's look at some graphing problems to start, and then we can go from there. So starting with number 1. So we have x squared over 9 minus y squared over 25 equals 1. Another thing to mention is that they are always set equal to 1, so like an ellipse. So in this case, our x comes first, so we know it should be a horizontal or a hyperbola because x comes first. So our general form is x minus h squared over a squared minus y minus k squared over b squared equals 1. So it's in general form. So we'll start by finding the center. So the center is not something it's asking us to find, but it is a valuable piece of information. So the center here would be at 0, 0 at the origin. The way we find our vertices is from the a value. So the a value tells us the distance from the center to our vertices. So here we know a squared is 9, so that means a would be 3 when we take the square root. So that means our vertices would be a distance of 3 from the center. So because this is a horizontal hyperbola, that distance has to be to the left and right of center. So here and here at 3, 0 and negative 3, 0. Okay. Let's think about our b values. So b squared here is 25, so that means b is 5. Because we take the square root. So that means our co-vertices would be 5 above and 5 below. So when we are graphing this, you can kind of create this imaginary box that uses those vertices and co-vertices as your edges. And our axes are going to be the lines that cut between the corners and the center of these boxes. So these are going to be our asymptotes. So when we graph, our hyperbola is going to trend along the lines of those asymptotes. So let's keep that in mind. Next, we have to find the foci. So remember, with hyperbolas, it's a squared plus b squared equals c squared. So a squared is 9, b squared is 25, so that means c squared is 34. So c is the square root of 34. So that's pretty close to 6, a little less than 6. So we'll have foci about here, a little less than 6 to the right, and a little less than 6 to the left. So those will be our foci at root 34, 0, and negative root 34, 0. So our hyperbola will trend towards these asymptotes around the foci. The last thing we need to do is be able to represent these asymptotes. So with horizontal and vertical hyperbolas, we do have formulas to represent them, like so down here. Y minus k equals plus or minus b over a times x minus h. Same with over here. Essentially, this is just like point slope form, because hk is a point on the line, and b over a is our slope. But b over a here, a over b there. But we could find it by doing it visually as well. So these are both going to be lines in slope-intercept form. So going from our center at 0, 0 to our first corner up here, we go up 1, 2, 3, 4, 5, over 1, 2, 3. So our slope there is going to be 5 over 3. And our y-intercept, the line we cross, is at 0, so just 5 over 3x. And the other is we go down 1, 2, 3, 4, 5 over 3. So our slope for the other would be negative 5 over 3x. And that would match up with our formula as well, because h and k are just 0. So we have plus and minus 5 over 3. But you can find it visually as well, so thinking slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So figure out your slope, figure out your y-intercept. Okay. All right, let's do another together. So for number 2, this one here is vertical since y squared comes first. So we know it's going to be vertical. It's already in our standard form. We can match that up. Let's see, how can I show this? There, so we have our y squared portion there, x squared there. There's no multipliers on the outsides. It's set equal to 1, so we're all set in terms of that. So let's identify our center first. So the center is going to be at negative 4, 0, since it's x minus h, y minus k. So 1, 2, 3, 4, 0. Next, we can figure out our a values. So we know a squared is 9. So that means a is 4. So since this is a vertical hyperbola, that means our vertices will be up and down from the center, a distance of 4. So we can go up 4 to get our first vertex, our first vertice, and down 4 to get our other. So our points will be at negative 4, 4, and negative 4, negative 4. To find the other edges of our box, we know b squared is 1, so that means b would also be 1. So we have these co-vertices here. Okay. So we're going to have these asymptotes here. Let's do the asymptotes first. So we have this point here. So going from the center to that corner, we go up 1, 2, 3, 4, over 1. So our slope is going to be 4. Our y-intercept, so we go up 4 over 1 to 8, up 4 over 1 to 12, up 4 over 1 to 16. So it's going to be plus 16. We could also use the formula. It's available to you. So thinking about this formula, it would be y minus k. So we think about our k value 0 equals a over b, so 4 over 1 times x minus h, so x minus negative 4 or plus 4. Sorry, that's just not great. So y minus 0 equals 4 over 1 times x plus 4. So y equals 4x times plus 16. Works that way too, so you're welcome to use that. And the same idea would follow for our other vertice, in that we would have y minus 0 equals negative 4 times x plus 4. So we'll get negative 4x minus 16. Okay, last thing to do is find the foci. So a squared plus b squared equals c squared is the way we do that. Our a squared is 16, b squared is 1. So c squared is 17, meaning c is root 17, so a little more than 4. So the foci will be very, very close to our vertices at negative 4 positive root 17 and negative 4 negative root 17. And there we go. Okay. All right, so we've got a couple more. Both of these are going to require a little bit of extra work to get it in standard form. So I'll start at least number 3 with you, and then I'll have you finish it on your own. So I'm noticing it's not set equal to 1, so let's just divide everything by 16. So we'll get 4 divided by 16 will give me 4 on the bottom, like so. So this would be our general form. So then pause the video, go from there, do the problem. Okay, we're back. So in this case, it is going to be horizontal because our x term comes first, and our center is going to be at the origin at 0, 0. Our a squared is 4 because a always comes first, and in this case that means a would be 2. So since it's horizontal, we would have points to the right and left of center. So 2, 0 and negative 2, 0. Our b value, or b squared, is 16, so that means b is 4. So we'll have co-vertices 4 above and below. Next, our foci. So a squared plus b squared is c squared, so plug in 4 for a squared, 16 for b squared, so we get c squared is 20, meaning c is the square root of 20. So the square root of 20, that's going to be somewhere between 4 and 5. So, or wait, sorry, this is a horizontal hyperbola, my bad. So they would be out here at root 20, 0, and negative root 20, 0. Or I suppose you could simplify that to 2 root 5. That would probably be a little better. So that would be our parabola. Let's draw in our asymptotes so that we can have a decent idea of what this hyperbola will look like. Okay. Last thing to do is write these asymptotes. So if we want to use that formula, it would be y minus k equals plus or minus. And since it's horizontal, it would be b over a for that slope times x minus h. So our k value is 0, our h value is 0, so we have y equals plus or minus. b is 4 and a is 2, so 4 over 2 times x, or just 2. So y equals plus or minus 2x. Sorry. Y equals plus or minus 2x for asymptote. And you could find it that way. We could check to make sure. So y-intercept at 0, we go up 2 over 1. Y-intercept at 0, we go down 2 over 1 for the negative 2x. Works the same. Okay. Moving on to number 4. So this is our last one. So you'll notice here, this is not looking like our correct form. So for us to go ahead and graph this, we need it in our standard form. So let's start by adding 16y squared to both sides, since I know x and y have to be on the same side. So that'll give me 16y squared minus 32y minus 9x squared equals 198.
I'm noticing we have a y squared and a y, so we're probably going to want to complete the square here. Let's start by factoring that 16 out of both of those terms. And now we can complete the square. So remember, to complete the square, you figure out what b over 2a squared is. So b is -2, a is 1, so we get -1, and -1 squared is just 1. So what that means is inside of these parentheses, I want to add 1. If I'm adding 1 to this side, I need to add to the right side too, but notice I'm not technically adding 1, I'm adding 16 times 1, so I should add 16 to both sides. Next, let's write this as a product of squares. So it'll be y minus 1 squared. And I'm getting that -1 from b over 2a. b over 2a is always going to be that value here, or you can just factor this out. What multiplies to c and adds to b? You're going to get -1 and -1. Then it's got to be set equal to 1, so let's divide everything by 144. So we'll end up with y minus 1 squared over, I believe 144 divided by 16 is 9. Yeah, that's correct. So over 9 minus x squared over 16 equals 1. So there's the
form we're going to want to be working with. So from here, y squared. If you'd like to pause the video and go ahead and do everything else on your own and then jump back in, you're welcome to. So I'll give you a chance to do that. Okay.
So this is vertical. Since y comes first, our center is going to be at 0, 1. Since our h would be 0, k would be 1. And it's going to be vertical. So in this case, a squared is 9, so that means a is 3. So our vertices will be 3 above and 3 below the center. So that is at 0, 4 and 0, -2. Our covertices will be 4 to the right and left, since b squared is 16, so b is 4. So we go over 4 to the right and left. So we can create our asymptotes.
Let's find our foci. So I'm going to do that work down here. So a squared plus b squared is c squared. So our a squared is 9, b squared is 16. So that means c squared is 25, or c is 5. So that means our distance from the center to the foci, going along that major axis, or rather, we call it the transverse axis, 5 from the center. So this is a vertical parabola, or hyperbola, so we're going 5
up and 5 down. So up 5 would be here at 6, down 5 would be at -4. So we have foci at 0, 6 and 0, -4. So we can draw our hyperbolas like so.
Okay. And last thing we do is write our asymptotes.
So this is a vertical. So we have y minus k equals, so up and over. So a over b plus or minus a over b times x minus h.
For our asymptotes. So that would be our general formula, where in this case, h is 0, k is 1. So we have y minus 1 equals plus or minus 3 over 4 times x minus 0, so just x. So we'll have y equals plus or minus 3 over 4x plus 1. So 1, we go up 3 over 4 or down 3 over 4. Yeah, that checks out. And there we have it.